Welcome friends to SSC CGL Tier 2 level quick algebra problem solving. This is Atanu Chaudhary of SureSolve. Continuing from the first part, in the second part of the video, we'll solve the last 5 questions of SSC CGL Tier 2 solution set 2 on Algebra 2 from suresolve.com. You will find a few interesting problems in this set of 5. But for now, let's see what lies ahead and start solving. Question 6 is, if a plus 1 by b equal to 1 and b plus 1 by c equal to 1, then value of c plus 1 by a is option A 1, option B 0, option C 2 and option D 1 by 2. This is a problem of variable elimination. First, get the value of b in terms of a from the first equation, 1 by b equal to 1 minus a, or b equal to 1 by 1 minus a. Now substitute the value of b in the second equation so that only c and a remain in the equation. You get b plus 1 by c equal to 1, or 1 by 1 minus a plus 1 by c equal to 1. Or 1 by c equal to 1 minus 1 by 1 minus a equal to minus a by 1 minus a. Rearrange and get the value of the target expression as c plus 1 by a equal to 1. Answer is option A 1. Important concept and technique used for solving the problem is variable elimination by substitution. The problem can be solved easily in mind. Let's solve the next question. Question 7 is, if a is to b equal to 2 by 9 is to 1 by 3, b is to c equal to 2 by 7 is to 5 by 14, and d is to c equal to 7 by 10 is to 3 by 5, find the value of a is to b is to c is to d. Option A, 8 is to 12 is to 15 is to 7. Option B, 4 is to 6 is to 7 is to 9. Option C, 30 is to 35 is to 24 is to 16. And option D, 16 is to 24 is to 30 is to 35. This is a two-stage ratio joining problem. But before you can take up joining the ratios, you must first convert the fraction ratio values to integers. The method to convert is to multiply both fraction values of a ratio by the LCM of the denominators of the two fractions. To show how the method of conversion works, let's first convert the ratio a is to b equal to 2 by 9 is to 1 by 3 to a ratio of integer values. LCM of the two denominators of the fractions 9 and 3 is 9. So multiply both the fractions by 9 to convert the ratio to a is to b equal to 2 is to 3. You could multiply both the fraction values by 9 because the two fractions actually are in the numerator and the denominator. That is, a by b equal to 2 by 9 divided by 1 by 3. In the same way, multiply the fraction ratio values of the second and the third ratios by 14 and 10 respectively to convert these to b is to c equal to 4 is to 5 and d is to c equal to 7 is to 6 or c is to d equal to 6 is to 7. The ratio of d is to c is converted to c is to d at this stage itself to make the ratio ready to be joined at the last stage. You could see that c would be the common variable during the last stage ratio joining, so that it must appear as the numerator of the third ratio. Let's now get on with our main task. To evaluate a is to b is to c is to d, you have to join the three ratios a is to b equal to 2 is to 3, b is to c equal to 4 is to 5, and c is to d equal to 6 is to 7. And joining the ratios would have to be done in two stages. First, you would join a is to b with b is to c. The common variable for these two ratios is b, with ratio values 3 and 4 respectively. Convert both the ratios so that the value of B for both are equalized to the LCM of 3 and 4, that is 12. So A is to B equal to 2 is to 3, or A is to B equal to 8 is to 12, and B is to C equal to 4 is to 5, or B is to C equal to 12 is to 15. Joining the two, now you get A is to B is to C equal to 8 is to 12 is to 15. At the last stage, you will join this with C is to D equal to 6 is to 7. Common variable between A is to B is to C and C is to D is C with values 15 and 6 respectively. Convert both the ratios so that C value becomes equal to the LCM 30 of 15 and 6. So the ratio values are changed to A is to B is to C equal to 16 is to 24 is to 30, and C is to D equal to 30 is to 35. Finally, joining these two, you get A is to B is to C is to D equal to 16 is to 24 is to 30 is to 35. Answer is option D, 16 is to 24 is to 30 is to 35. Important concepts and techniques used for solving the problem are fraction ratio value normalization by expressing the values as integers with no common factors, joining ratios step by step, base equation to the LCM of the values corresponding to the common middle variable, and LCM. Though the solution seems to be long, the conversions are easy to do wholly in mind. Let's solve the 8th question. Question 8 is, if A and B are the roots of the equation 3x squared plus 2x plus 1 equal to 0, which of the equations will have the roots 1 minus A by 1 plus A and 1 minus B by 1 plus B? Option A, y squared minus 2y plus 3 equal to 0. Option B, y squared plus 2y minus 3 equal to 0. Option C, y squared minus 2y minus 3 equal to 0. And option D, y squared plus 2y plus 3 equal to 0. To solve this question, you have to use relations of sum and product of two roots of a quadratic equation. Let's say C and D are the two roots of a general quadratic equation, x squared minus px plus q equal to x minus c multiplied by x minus d equal to 0. Or x squared minus c plus d multiplied by x plus cd equal to 0. The sum of the two roots is then c plus d equal to p, the middle term, and the product of the two roots is cd equal to q, the numeric term. This is the main concept to be used in two stages to solve this problem. First, we normalize the given quadratic equation 3x squared plus 2x plus 1 to convert the coefficient of x squared to 1 by dividing through with 1 by 3, with the result x squared plus 2 by 3x plus 1 by 3 equal to 0. So sum and product of the roots a and b are a plus b equal to minus 2 by 3 and ab equal to 1 by 3. As the given root values are cumbersome, for convenience of manipulations, you will use dummy variables p equal to 1 minus a by 1 plus a and q equal to 1 minus b by 1 plus b. From the choices you find that absolute values of p plus q and pq are 2 and 3 for all the choices and differ only in sign. So you decide not to evaluate p plus q and pq and focus on finding only the signs of the two. Both p plus q and pq will have denominator as 1 plus a multiplied by 1 plus b equal to 1 plus a plus b plus ab. The denominator will then be positive and we'll ignore it from further consideration altogether. Next, the numerator of PQ will be 1 minus A multiplied by 1 minus B equal to 1 minus A plus B plus AB. And we can immediately say that it will be positive. So the numeric third term of the quadratic equation will be PQ equal to plus 3. Finally, the numerator of P plus Q will be 1 minus A multiplied by 1 plus B plus 1 minus B multiplied by 1 plus A equal to 2 minus 2AB, which will be again positive. Thus, the middle term of the quadratic equation will be P plus Q equal to plus 2. The desired equation will then be y squared minus 2y plus 3 equal to 0. Answer is option A, y squared minus 2y plus 3 equal to 0. Important concepts and techniques used for solving this problem are relationships between the roots of a quadratic equation and product of roots and sum of roots concepts. Let's take on the ninth question. Question 9 is, if 2x squared minus 7xy plus 3y squared equal to 0, then the value of x is to y is option A 3 is to 2, option B 5 is to 6, option C 2 is to 3, and option D 3 is to 1 and 1 is to 2. By midterm splitting method, factorize the given quadratic equation to 2x squared minus 7xy plus 3y squared equal to 2x minus y multiplied by x minus 3y equal to 0. This will give you two relations between x and y satisfying the quadratic equation as 2x equal to y or x is to y equal to 1 is to 2 and x equal to 3y or x is to y equal to 3 is to 1. So the ratio of x is to y has two values for two zero-valued factors, 1 is to 2 and 3 is to 1. Answer is option D, 3 is to 1 and 1 is to 2. You can otherwise solve this problem practically instantly by observing that given equation is not a whole square equation, and so it would have two zero-valued factors resulting in two ratio values for x is to y. As only option D has two ratio values, it must then be the answer. Important concepts and techniques used for solving the problem are factorization of quadratic equation, basic ratio concepts, and mathematical reasoning. Let's solve the last question. Question 10 is, find the value of alpha when the expression x squared by y squared plus alpha x plus y squared by 4 is a perfect square. Option A plus minus 1, option B 0, option C plus minus 2, and option D plus minus 7. Compare the like terms of the given quadratic expression with a perfect square quadratic expression, which is a plus b whole square equal to a square plus 2ab plus b square. The first square term would be a square equal to x by y whole square or a equal to x by y. And the second, b square equal to y by 2 whole square or b equal to y by 2. For the given quadratic expression to be perfect square, then the middle term must be 2ab equal to 2 multiplied by x by y multiplied by y by 2 equal to x. So alpha x equal to x or alpha equal to 1. But you have considered only the perfect square form of a plus b whole square. For the form of a minus b whole square, the middle term will be minus 2ab equal to minus x, and the desired value of alpha will be alpha equal to minus 1. So taking account of both forms of perfect square, the value of alpha will be alpha equal to plus minus 1. Answer is option A, plus minus 1. Important concepts and techniques used for solving this problem are forms of a perfect square and comparing like terms of two quadratic expressions. To read the detailed solutions, refer to the corresponding article in our website sursolve.com. Link is given in the description of this video. Lastly, please do subscribe to our channel for latest uploads. Thanks for your time.